Fair lending analysis is becoming increasingly technical, which means a basic understanding of statistics is becoming increasingly important. This video is the first in a series of videos aimed at refreshing your memory on, or perhaps teaching you for the first time, statistical concepts that are fundamental to fair lending analysis. We begin by addressing the question, what is a distribution? Understanding the answer to this question is fundamental to understanding statistical inference. In other words, to understand common terms like statistical significance, t-scores, z-scores, or p-values, you must first understand what is a distribution. A distribution can be best understood as a histogram of data. Take, for example, female shoe sizes in the United States. If we collect a sample of data and put them in the 4 bins listed here, the data might look something like this. If we narrow the bins, the histogram might look something more like this. If we were to continue narrowing the bins to very small bins, the distribution will resemble a bell-shaped curve. As you can see, the bell-shaped curve is just an approximation of the histogram of the data. While there are many types of distributions, one of the most well-known and commonly used distributions is the normal distribution, which is illustrated here by this bell-shaped curve. In a normal distribution, the mean equals the median and the mode. Perhaps the most popular use of the bell-shaped curve is by teachers who grade on a curve. This means that when a distribution is skewed, perhaps the average exam grade in a class is a 60, with many students scoring very low and only a few students scoring very high, the teacher may adjust the scores to more closely resemble a normal distribution. So what does all this have to do with fair lending analysis? In fair lending analysis, we often use regression analysis to estimate the relation between some protected class and the price of a loan. When we do this, we often use the least squares estimator. When we engage in estimation, we know that there is some true relation between this protected class and price that we often label beta, and the least squares estimator estimates this relation based on the data in our sample. We often label this with a lowercase b. The result is only an estimate of the true relation, and we will never know if our estimate is exactly correct. But by using what we know about the distribution of the data, we can infer some conclusions about the relation between the protected class and the price of a loan. In the next video of the series, we will cover more precisely how we actually use what we know about the distribution to do this.